Okay, we're going to practice some more of these integrals, and we're going to kind of do it the fast way where we have the integral of some function of u, and then we're going to try to get the du dx right here, right next to the dx, and the reason we do that is so the dx's will cancel, and so we'll just be left with a du. So we'll have an integral that's some function of u, and then du. For this example, we're going to choose that our u is sine inverse of x. And if you remember the rule, the derivative of sine inverse is all this stuff here. So it's 1 over the square root of 1 minus x squared. So what we're going to do is we're going to plug in our u. So our u is right here. Then we're going to move all this stuff over. So my dx is going to come here, and all the other stuff is going to come right here. Now we want a du dx right here. And it turns out we're lucky because du dx is already sitting right there. Okay, so we have our du dx here right next to our dx. So we can cancel the dx's, and we'll just be left with a du. So we just have the integral of u du. That's an easy integral. Our answer is going to be u squared over 2. And we can't forget to plug the u back in. Our u was sine inverse of x. Don't forget that it's squared. And we're dividing by 2, so I'm going to put a 1/2 in front of it. And of course, we don't want to forget our plus c. And there we go. That's our final answer in the green box. Okay, for the second one, the entire bottom piece is going to be our u. And if we do the derivative of 1 is 0. The derivative of sine is going to be cosine. But if you look at the inside, we got to do the chain rule. The derivative of 5x gives you 5. So that's important. Our du dx is here. So we want this to be du dx. We want these two things to match. We are missing a 5. Otherwise, it's exactly the same. So we need to put a 5 right here. So if we can get a 5 right here, we will have a du dx right next to the dx. And then, of course, the dx's will cancel, and we'll just be left with a du. So how can I get a 5 in here? Well, I got to put 5 over 5. That's the same thing as multiplying by 1. And I don't need this 5 that's on the bottom, so I can bring it out to the front. That'll be a 1 over 5 in the front. And now I'm basically done because this is du dx. So now I have du dx sitting right next to my dx, so the dx's cancel, and so all that stuff turns into my du. I can bring down my 1 over u. Don't forget to bring down your 1 over 5. That's just a constant, so it'll just stay on the outside. Now this is a really easy integral to do. This is going to be ln of absolute value of u plus c. Don't forget your 1/5, and don't forget to trade your u for all of that stuff. And there we go, there's our final answer. Let's put a box around it. The answer's in the green box. Okay, for this example, our u is going to be 5x. So the derivative of u is just going to be 5. So we can plug in a u for the 5x. And since the derivative of u is 5, we just need a 5 right here. We have a 1, so we can put a 5 over 5. And we don't need the 5 that's on the bottom, so we could bring it out to the front. That'll be a 1/5 in the front. And now we have our u prime right next to our dx, so the dx's will cancel, and we'll just be left with a du. Now you might notice that we have 1 over sine squared, and 1 over sine is the same thing as cosecant. So if we have 1 over sine squared, that's the same thing as cosecant squared. So our integral is going to be the integral of cosecant squared. And there's a reason why we changed it to cosecant squared instead of just leaving it as 1 over sine squared. We actually have a rule for that. If you remember, the derivative for cotangent is equal to negative cosecant squared. So we can go backwards. We can say the integral of negative cosecant squared is going to give us cotangent. Now we don't have a negative, so we can put a negative in here as long as we put another negative on the outside. That's kind of like -1 times -1. And now this integral right here is going to just give us cotangent. Okay, do not forget this negative over here. We have to put a negative in the front. And do not forget to trade the u for 5x. Okay, there we go. There's our final answer. We'll put it in a box. And that's it. Okay, for this one, we're going to choose everything in that box for the u. So that's kind of like 3x times 3x times 3x. So you can see we have 3 times 3 times 3 gives you 27, and x times x times x gives you x to the third. Now if we do the derivative, the 3 comes down, you get 81, and your new power is 1 less. So your new power is x squared. Remember, 27 times 3 is the same thing as 3 times, and 27 is 3 times 9. So you have 9 times 9, and that's where I'm getting the 81 from. So since our u prime is 81x squared, we want an 81x squared sitting right here. We can plug in the u for all this stuff, and we can move the x squared over right next to the dx. But we still need an 81 in front of the x squared. So I'm going to have to put 81 over 81, and I don't need this 81 on the bottom here, so I'm going to move it out to the front. It's going to be a 1 over 81 in the front. And now I do have an 81x squared, so my du dx is sitting right here, right next to the dx. So if your du dx is sitting right next to the dx's will cancel, and you'll just be left with du. Okay, remember the rule, the derivative of cosine is negative sine. So we want to go the other way. The integral of negative sine is going to give us cosine. Of course, we are missing the negative, so let's put a negative inside here. We're also going to have to put a negative on the outside. It's kind of like negative 1 times negative 1. Okay, so this entire integral is going to give us cosine of u. Don't forget the constant, negative 1 over 81. Don't forget your plus c. And don't forget that your u was 27x to the third. So we'll plug that in right here. And that's our final answer. Let's put a box around it. And that's it. Okay, for this one, we're going to choose e to the 5x for our u. And when we do the derivative of e to the 5x, we get e to the 5x. But then we got to do the chain rule, because not just an x, is a 5x. So we do the derivative of 5x, and we get an extra 5 down here. So our u prime is going to be 5 times e to the 5x. Now we're trading e to the 5x for our u, and we can move this stuff over, along with the dx, sitting right here. And remember, we need 5e to the 5x, but we just have e to the 5x. So we're missing a 5. We need a 5 right here. So we're putting a 5 over 5 right here, and we don't need that 5 on the bottom, so we can bring it out to the front. It'll be a 1 over 5 in the front, and now we're just left with a 5e to the 5x. Remember, 5e to the 5x is exactly what we wanted. That's our du dx. And so now we have a du dx sitting right next to our dx, so the dx's will cancel, and we'll just be left with a du. Now remember, the derivative of sine is cosine, so that means the integral of cosine is just going to give us sine. So this integral right here is just going to give us sine of u. Don't forget the plus c, and don't forget the 1/5 in front. And the last thing, your u was supposed to be e to the 5x. Okay, that's your final answer. Let's put a box around it. And that's it. Okay, for this one, our u is going to be x to the 4th plus 4x squared. We can do the derivative. The derivative of x to the 4th is going to be 4x to the 3rd. And the derivative of 4x squared is just going to be 8x. Now I'm going to factor out a 4 from this. And that's going to leave me with x to the 3rd plus 2x. So over here, I can plug in my u for the x to the 4th plus 4x squared. And then all this stuff I'm going to bring over here. I'm hoping to get du dx here right next to my dx. So I need a du dx here. My du dx is going to be 4 times x to the 3rd plus 2x. I already have an x to the 3rd plus 2x. I just don't have the 4. So I need to put a 4 right here. So I'm going to multiply by 4 over 4. That's the same as multiplying by 1. I don't need this 4 on the bottom, so I'm going to bring it out to the front. That would be a 1 over 4 in the front. And now I have my du dx. My du dx is sitting right next to my dx. So again, we can cancel these dx's, and we're just left with a du. So now our integral is just an easy power rule. We're going to add 1 to the power, and then we want to divide by that new power. Don't forget your plus c, and don't forget your 1/4 in the beginning of your integral. And the last thing was that your u was x to the 4th plus 4x squared. We can do a little simplifying. The 4 times the negative 10 is negative 40. And if you have a negative 10 power on top, you can move the entire piece down and it will become a positive 10 power. Okay, and you can even bring this 40 down to the bottom so it's just one fraction. Okay, that's our final answer. Let's put a box around it. And that's it. Okay, for this one, we're going to choose all this stuff for the u. And we're going to simplify it before we do the derivative. So this is x to the power of 5. We can actually bring this 5 down in front, so it's 5 times ln of x. So now we can do the derivative. The derivative of 5 is 0, and we have a plus. And then we're going to do the derivative of 5 times ln of x. So the 5 is a constant. You can ignore it. You just bring it down. And the derivative for ln of x is 1 over x. So our du dx is going to be 5 over x, or 5 times 1 over x. That's the same thing. Now over here, I'm going to trade all this stuff for the u. I'm left with 1 over x and dx. Now I would like this to be my du dx. Remember, my du dx is 5 times 1 over x. It looks like I'm just missing the 5. So if I can get a 5 over here, then I would have a du dx sitting right here. So I want to put a 5 over 5 to start with. And I don't need the 5 on the bottom, so I'm going to move that out to the front. That'll be a 1 over 5 in the front. And now I do have a du dx sitting right in front of my dx. So I can cancel the dx's, and I'm just left with a du. Okay, this is actually an easy integral to do. It's just going to be ln of absolute value of u. Don't forget your plus c. And don't forget this constant out in front, the 1/5. And our original integral was a function of x, so we can't leave this u here. We're going to have to trade our u for 5 plus 5 ln of x. And that's our final answer. Let's put a box around it, and that's it. Okay, for this one, we cannot choose the bottom for our u because the derivative would be 162x, and we don't have any x's on top. We just have a dx. But we do have this rule that the derivative for tangent inverse is 1 over 1 plus x squared. So that means the integral for 1 over 1 plus x squared is just going to give us tangent inverse. So we want this to be 1 over 1 plus something squared. So we want to change this 81x squared into 9x times 9x, which is 9x squared. And now our u is just going to be the 9x. If we choose u equals 9x, then the derivative of u is just going to be 9. So we'll put a u for the 9x. And now we just need a 9 in this spot right here. Right now we just have a 1 there. So we're going to need to put 9 over 9. Now we don't need the 9 on the bottom, so we'll move that to the outside. It'll become 1 over 9 on the outside. And since our du dx is just 9, we have a 9. So that means we have our du dx, and it's sitting right next to our dx. So we can cancel the dx's, and we'll just be left with du. Now this integral here is just going to give us tangent inverse of u. And don't forget the 1/9 in front. Don't forget the plus c. And don't forget that your u was equal to 9x. And that's it. That's the final answer. Let's put a box around it, and we're done. Okay, here's our last one. We're going to choose 5 over x for our u. 5 over x is kind of like 5 times 1 over x. And if it's x to the power of 1 on the bottom, we can move it up, and it will become x to the power of negative 1 on top. So we're rewriting it a little bit, and now we can do the derivative. The negative 1 will come down, and the new power will be negative 2. And x over negative 2 is the same thing as 1 over x squared, but that's going to be our du dx. We want negative 5 times 1 over x squared, and that'll be our du dx. We need that right here. Remember, 5 over x was our u. So that's how we're getting sine of u. The 1 over x squared is right here, and our dx is right here. So our du dx needs to be negative 5 times 1 over x squared. So we're just missing our negative 5. If I can get a negative 5 here, then I'll have my du dx sitting right there. So I want to put a negative 5 over negative 5 there. That's how I'm going to start. And I don't need the negative 5 that's on the bottom, so I'm going to bring it out to the front. That'll be a negative 1/5 in the front. And now I have my negative 5 times 1 over x squared. So if you remember, that's my du dx. And since I have my du dx sitting right next to my dx, I can cancel the dx's, and I'm just going to be left with a du. Now remember, the derivative of cosine is negative sine. So if we go backwards, the integral for negative sine is just going to give us cosine. Now we don't have a negative sign, we just have a sine, but I can put a negative inside and then another negative on the outside. So this negative 1/5 that's on the outside is going to become positive because we have two negatives, so that will make it positive. Okay, this integral here is just going to give us cosine of u. Don't forget the 1/5. Don't forget your plus c. And don't forget that u was just equal to 5 over x. And that's it. We'll put a box around it. And that's our final answer.